Okay, on we go in section 5 in the text when we were considering the case where mu was actually greater than 4, which meant, let me get myself a bigger one to play with here now, which meant that the graph of our function went outside the box, like that. And so what we could see there is that there's a collection of points here, so that everybody in between here, if you iterate, you go outside the box, which means you're over here, and you're down here, and you go toward infinity. So these are the points that our text calls a sub 0, and I think of the a as standing for these are the points that go away. I don't know, it's just simple. So one question might be, is this, it's obviously an interval, but is it an open interval or a closed interval? That's, of course, determined by the endpoints. And what happens to the endpoints? The endpoints are exactly the point where you nick the edge of the box. And if you hit the top of the box, then vertically to the curve takes you horizontally to the reference line exactly in the corner. There's the corner. And then you come down and you go exactly to 0. So the endpoints here go to 0, which means they don't go to infinity. They stay in forever. So if this is a collection of points that go away, that's going to be an open interval. The folks inside go away because anybody inside here just a little bit. Then when you go up here, you're actually just a little bit outside the box. Then you'd be outside here, and you'd go down, and then you'd be going off toward minus infinity. So what happens is that we tend to call this interval I is the interval from 0 to 1. It's very standard sort of notation. And so what they like to do is to say that this exit set, the set of points that goes away, breaks this original interval into I sub 0 and I sub 1. And that's going to be a handy name for bookkeeping and keeping track of what's going to be happening later on. So what we want to do now is figure out what happens to some other points, and that is going to amount to sort of tracing ourselves backwards. Because now all you have to do is imagine that anybody over in either I0 or I1 that you could plug into the function and have the y value end up in here or in here. Then when you go horizontally to the line and vertically to the curve, then you're exiting, which means anybody is going to be leaving after another iteration. If after one iteration they're in A0, then another iteration they're outside. So we're just going to build up this collection of intervals. And you can actually trace them sort of backwards from the picture. Because if I go directly, if I undo my usual thing, which is now I go sort of horizontally to the curve, then I go vertically down here to the axis. I go to the other edge here of this A. It goes up to here. And so if I go horizontally to the curve, which is exactly the backwards of usual, and I go vertically down to the axis, then what I find out is anybody in there, if I go curve, line, curve, that's exactly where I thought I wanted to be. These are folks that as you iterate them once, they're in A0, and then if you iterate again, you go outside. But wait, when I was going from the edge of A0, and I went up to the curve, and I said, let's go horizontally, up to the reference line, to the reference line, if I now go horizontally to the curve, which is, again, since we're going backwards, we're doing the opposite of our usual routine. So if I go horizontally to the curve, well, I can look left and right. I can go this way and also go to the curve. And then look straight down, and I got the edge of a point. And the same thing up here. This was the other edge of A0. So if I go up to the reference line there, and then instead of going horizontally to the curve that way, I could also go horizontally to the curve and end up that way. And then I look straight down. Then I get another interval. And you know, that's exactly consistent with what we were yapping about before, and that is that each one of the members of this family does a 2-for-1 deal. I mean, everything that this one does going up until it reaches the vertex, it repeats itself over here. So that means if you're talking predecessors of points, if you're talking pre-images of points, anybody in this whole height of the parabola, which in this case covers the whole 0, 1 interval, is going to have two predecessors. And so if we're going to call this set A1, A1 is the union of those two guys, because anybody in there is, if you go vertically to the curve, horizontally to the line, vertically to the curve, you're out, just like we said. And again, those are open. Just for fun, let me try the next one really briefly with back to the black ink. Well, we can find predecessors for these exactly the same way, and then we'll start seeing a pattern here. Okay, so if we want to find out what ends up in A1 under one iteration, then it would end up in A0 after two iterations, and it would end up out next. Well, we can go vertically to the line. Again, it's the opposite of what it used to be because we're thinking pre-images. So we're going backwards. So if you go vertically to the line and then you go horizontally to the curve, well, there's horizontally to the curve, and then this is also horizontally to the curve. So we get 1 point down there and 1 point down there. So now if we look at the other edge of this piece of A1, remember there are two pieces of A1, if we look at this other edge, and remember we're doing it backwards because we're trying to find pre-images, and that is we go vertically to the line and horizontally to the curve. Horizontally to the curve has two answers. And then we look down and see where we are, then sure enough, that little interval there is anybody who's going to end up, if you go in here, you end up in A1, and then in A0, and then your history. And look down from that other little horizontal peak over here, and you get another one over there. So that's a piece of what we're inevitably going to call A2. Right? So we got two pieces there. But now we can do the same thing with the other piece of A1. Right? If we go vertically to the line, which seems kind of backwards, strange. Vertically to the line now is going outside the curve. But don't panic, because now we have to go horizontally to the curve, and one of them is there and one of them is over here. And so we look down from that one and we get a point, and we look down from that one and we get a point. Then if we go to the other side of A1 and we try to say, where do those folks in there come from? We're doing pre-images, so we're doing the opposite of our usual routine. So you go vertically to the line. Oh, vertically the line is way out, way past the curve. Well, that's cool. So we go now horizontally to the curve, and there's also horizontally to the curve. Then if you look down there, it comes down with that guy, and there's a little interval there. Where was that one? Over there, a little bit to the left of that, and there's one over there. So there's 1, 2, 3, 4 pieces of, well, that was A0, that's A1. This 4-piecer we're going to call A2, and so on. So that's getting to look pretty slobby as a picture. The question is, then each piece, when you look for predecessors in the orbit, is going to have two separate pieces, but they're getting smaller. So the question is, does it then fill out and everybody ends up leaving? And of course the first answer to does everybody leave is no, because just think about this. Every single endpoint of one of these little A guys was the edge of who went to the endpoint of the next level. So this edge of this piece of A2, when you iterate it, ends up at the edge of A1, and the edge of A1, when you iterate that, ends up at the edge of A0, and the edge of A0, all these edge guys are the ones that land right on there, which means they go to 0, and they stay at 0. They don't go to minus infinity. So all the endpoints of all the intervals of the pieces of A0, A1, A2 stay inside forever. So the first fear, or the first question might be that if you iterate this, if you keep finding the pre-images of who ultimately ends up in A0, does everybody end up in A0 so everybody goes away and ultimately nobody's left inside the box? The answer is no. In fact, from the construction, we keep picking up more and more and more folks who stay inside forever. So that brings up the general description of what this set is like. Who's leaving and who stays behind. So time out for just a minute.